Okay. We have to catch up with our lessons on hydrostatic pressure, but before that, i-review natin yung principles of hydrostatic pressure. So this is the problem dun sa ating unang presentation, the sample problem. Given the atmospheric pressure of 920 millibars and a gauge that is attached to a tank rates 400 millimeters of mercury. The reading is a vacuum pressure and you are required to determine the absolute pressure. Okay, so you remember the conversion of quantities. We have to be consistent with units. 1 bar is equivalent to 100 kilopascal. So the given atmospheric pressure of 920 millibars is converted to kilopascal. So 920 millibars is 0.92 bars. Converting it to kilopascal, that becomes 92 kilopascal. Okay. Now the problem states that the reading on a tank is 400 millimeters of mercury vacuum. So that is a gauge pressure. This is a measurement of the gauge pressure on the tank. So the gauge pressure is equal to the unit weight of the fluid that causes the pressure. In this case, it is mercury that stands at a height of 400 millimeters or 0.4 meter. So this one is the unit weight of mercury multiplied by the height, its height, which is 400 mm. So we just directly substitute the unit weight of mercury is equal to the specific weight of mercury, which is 13.6 times 9.81 times the height of 0.4. Now showing you how consistent we are with the units. Okay, 9.81 is the unit weight, kilonewton per cubic meter. This is the height in meter. So i-cancel natin yung meter over cubic meter, magiging square meter. And 1 kilonewton per square meter is kilopascal. Okay, always remember class that when you write a quantity which is nanggaling sa pangalan ng isang tao, they are all capitalized. Newton, Pascal, these are people. Kaya yan ay units that are naka-caps lock yan. Okay, kilopascal. So, this is the quantity, 53.37, but sabi sa problem, it is a vacuum pressure. So, pag sinabi mong vacuum pressure, it is below the atmospheric. So, it bears a negative sign. So, finding the absolute pressure, the absolute is equal to atmospheric plus the gauge pressure. So, add lang natin ito. Okay, but this one is negative. So, the absolute pressure at a point or in the tank is 36.83. Okay, another sample for principles of hydrostatic pressure. Ginagamit din yon yung mga principles na yon in the manometer problems. In this problem, nakikita nyo dito ay differential manometer. Meron tayong dalawang pipes. Okay, ito yung cross-section ng dalawang pipes kung saan merong ito yung dalawang conduit kung saan merong flow A and B, pipes A and B, and then nag-insert ng manometer, a U-tube. Okay, then we have the gauge fluid here, mercury. Siyempre, nasa ilalim yung mercury kasi mabigat yung fluid na yan. So, ito yung gauge fluid at yung mga reading are shown. The readings on the manometer are shown. From A to 0.2 is Y, and then from 1 to 2 is 0.1. Yun ang mga interfaces of the two liquids in this manometer. Now, B is lower than A by 1.5 meters. The problem requires you to find the pressure head difference between A and B, pipes A and B, in meters of water, and in meters of mercury. Kasi silang dalawa, yung dalawang pipes na to are not in the same elevation, natural na hindi parehas ang pressure do sa dalawang points na yon. Kasi sabi natin, one of the hydrostatic principles is that at any point in the fluid at rest, at any horizontal plane, the pressure is the same. So, ito, yung horizontal na yan, pare-parehas yan. Ito, horizontal pero of different elevation. So, may pressure difference between A and B. So, how do you solve manometers problems such as this? Applying the principles of hydrostatic pressure, nilagyan natin ng numbers. Yung interface between water and mercury, this is 0.1. This is an interface between water and mercury, 0.2. Pero sabi nga, along in a horizontal plane, the pressure is the same. So, 2, 2, 2, naka-horizontal yan, pare-parehas ang pressure. 1, 1, magkaparehas ng pressure yan. Then, kuhanin natin itong equation na to, that the pressure at point 1 is equal to the pressure at point 1 dito sa right side ng manometer. So, ano yung pressure at point 1 dito sa left side of the manometer? The pressure at point 1 can be obtained by this equation. Ito ipo-formulate natin. Pressure at 1 is equal to the pressure at A. Pag ikaw ay pataas, mababawasan yung pressure. So, PA minus the unit weight of water that stands Y. Okay? So, andito ka na ngayon. Equal ang pressure dyan. Okay? Tapos, from 2 to 1, pababa. So, it is plus. Ayun. Plus, ano yung fluid na yun? It's mercury that stands 0.1. So, nandito ka na sa 1. Okay. Then, equal daw yun sa pressure at 1 dito sa right side of the manometer. Ano naman yung pressure at 1? That is caused by the pressure at B minus this height. At yung height na yun ay 1.5 plus Y. So, andito ka na sa 0.2. Then, minus or plus. Kasi pababa ka, plus the unit weight of water that stands 0.1. And we are required to find the pressure head difference, not the pressure. So, lahat na yan, lahat ng quantities na yan is to be divided by the unit weight of water. Okay? Because this is, H is equal to pressure over the unit weight. This is a pressure head. So, lahat na yan, i-divide natin by the unit weight of water. Yun yung nire-require sa atin. Pressure head difference in meters of water. So, lahat na yan, dinivide natin sa unit weight of water. So, that is the pressure head difference in meters of water is 2.755. If you are going to solve for letter B, pressure head difference between A and B in meters of mercury, ito naman ang divisor nyo ngayon, puro yung unit weight ng mercury. Okay? So, yun yung magiging answer nyo. And definitely, pag unit weight of in meters of mercury, this quantity will be very small because mercury is a very heavy fluid. And then, what else? Okay. Kung kasi, okay, nagkaroon lang tayo ng maliit yung space, so nakita nyo na, nung simplify natin yan, PB minus PA. Kasi, kung yan ay PA minus PB, this will be negative. Okay. Okay, let's discuss now the finding the total hydrostatic pressure on surfaces. Dito sa topic na to, ang tatandaan nyo lang is how to determine the position of the resultant or the total hydrostatic pressure on surfaces. And you have to review how to determine sa mga plane surface, ano yung moment of inertia. Okay, so let's have this problem. You are shown here a plane surface, a rectangular plane surface, 1.5 by 3 ang kanyang dimension. And it is the topmost part of this object is just flush at the water surface. Okay. So, kung ang plane surface na ito, alam naman natin yung tinatawag na centroid o kaya ay center of gravity. The centroid of this surface is kalahati nung width saka kalahati nung height. So, nandun yun. That's the center of gravity. If this is immersed in a fluid at rest, and you are going to look at it on the side view, ito yung side view ng surface na ito, ito ay acted upon by hydrostatic pressure. Okay. At sabing ganon, doon sa ating previous chapter,
Go!
Okay, at doon sa previous chapter, sinabi natin that pressure varies with depth. So, mula dito, which is atmospheric, pressure varies with depth. So, ibig sabihin, papalaki yung pressure. So pag dinrawing natin yung pressure diagram from 0 here to maximum at the bottom. So parang nakaka-drawing ka ng isang diagram na triangular. So ano ba yung saan yung centroid ng triangular surface na yan? Yun yung point kung saan yung resultant ng pressure that acts on the body is acting. At ang tawag doon ay center of pressure. Doon itong resultant pH na ito ng hydrostatic force acting on the surface ay nandun sa CP, center of pressure. At yun ay E distance below the center of gravity. Lagi siyang nasa ilalim ng center of gravity by an amount which we call the eccentricity E. Now the problem is for you to determine the total hydrostatic pressure resultant. Resultant ang ibig sabihin mo, big letter T. The resultant hydrostatic pressure acting on the surface is equal to the unit weight times barred H times A. Okay? So ang unit weight nito, ano ba? The tubig yan. So unit weight of water. Yung barred H ay yung mula dun sa surface ng fluid o ng tubig ay yung distance niya hanggang dun sa centroid o dun sa center of gravity. So the center of gravity is 1.5 meters, kalahati nung 3. Kaya yun, 3/2. At yung area that is subjected to hydrostatic pressure is 3 by 1.5. So yun ang ating total hydrostatic. The resultant of the force acting on the surface is 66.22 kilonewton. And saan ito nag-a-act? Where is this pH acting? It acts at the center of pressure that is E below the center of gravity. So kailangan kuhanin natin yung E, the eccentricity E. And that is obtained by the formula Ig/A barred Y. Okay? Pagka ang isang surface ay kamukha nito, vertical, yung ating barred H ay equal sa barred Y. Okay? Kasi hindi siya naka-incline. So, yung barred Y natin is also the same as 1.5. Okay, 3/2. So, ang Ig, this is the moment of inertia of a rectangular surface, 1/12 BD cube. I hope you remember that. So, substitute mo lang. The base is 1.5. The depth is 3 cube. So, ang E natin is 0.5. So, ang CP natin ay 1 meter. Okay, the center of pressure is 1 meter from the bottom. Okay, yun ang ating E. Now, if you are going to have this, the same body immersed in the same body of water, yung top niya is 2 meters from the surface of water. Ito naman, ilulubog na natin ng mas malalim, the same rectangular object na ito, 1.5 by 3. So ano ngayon yung saan nandun ngayon ito? Okay, again, ilocate natin yung point of action ng total hydrostatic pressure. Okay, so P, we have to find P, the unit weight times barred H times A. In this case, ang barred H na natin, yung pa rin naman ang center of gravity ng 1.5 by 3. Kalahati ng 3, pero hanggang doon sa water surface plus 2. So again, ang ating barred H na tinatawag ay mula doon sa center of gravity hanggang doon sa surface ng fluid. Then A is still the same, the same object experiencing hydrostatic pressure. So that's substitute lang. P is 154.51. And you have, okay, again, yung CP. Asan ngayon ang center of pressure natin? So, kung ito-drawing ulit natin yung ating hydrostatic pressure diagram, mula dito is 0, kasi atmospheric ito atmosphere yan. So, the gauge pressure is 0, increasing gradually hanggang doon sa bottom. Ito yung maidodrawing natin na pressure diagram. Pero ito lang naman, hanggang dito lang naman yung ating that is the height. So, para ka ngayon may trapezoidal. Asan ngayon yung centroid ng trapezoidal section? So, makukuha mo ngayon itong E, the same formula, Ig/A barred Y. So 1/12, the same object is 1.5 by 3 cube. And A is area of this rectangular section. Pero yung ating barred H ay equal sa barred Y which is equal to 2 plus 1.5, which is 3.5. So, ang E natin, yung eccentricity, yung distance between center of gravity and the center of pressure is 0.214. Kaya kanina, okay, yung ating yung ating pH, the total hydrostatic pressure is 1.286 meters from the bottom. Kanina is 1.5. Okay? There's sample of finding the total hydrostatic pressure, and each location is shown here with a sector gate. Okay? This is the sector gate. It is hinged at O and resting on this smooth surface at point A. Now, the sector gate is 20 feet in radius, and the topmost part of the sector is C, okay, and it is just flush with water surface here. So, in the figure, makikita nyo, tinatanong sa inyo ano ba yung pH at yung PV. Kasi, this is the surface. This is the surface. So, the surface is subjected to hydrostatic pressure kasi alam naman natin, the pressure is always perpendicular to the surface on which it acts. Pero yung ating surface ay curved. Okay, curved surface ito. So, yung resultant niya ay mas mahirap kuhanin kasi nakakurba. So, ang mas maganda is to resolve the total pressure acting on this curved surface into its horizontal and vertical component. Yun ang pinakamadali kasi mas madali siyang makita yung mamaya when we take moment about O, makikita na natin yung mga moment arm niya. Madali siyang i-locate. So, okay, pH as defined is equal to the weight of the volume of fluid acting horizontally, the total weight. So, ito ngayon, tubig yan. So, this is the unit weight of water. We are using the unit feet. Ito yung English system pa. So, the standard unit weight of water using the English system is 62.4 pounds per cubic foot. Okay, ano yung barred H? Yung barred H, kung ipo-project natin, may horizontal projection itong curve na ito, at ito ay mayroong length. Okay, mayroong length siyang 30 feet. Okay, what is this height? So, sine ng 60 yan. Sine ng 60 is equal to this over 20, so that is 17.32. Itong height na ito is 17.32. So, ano ang center of gravity ng 17.32? Kalahati. Okay? Rectangular area na may height na 17.32 ay may centroid na sa kalahati ng height. And what is the area? Kung imagine niyo na yung pinroject natin na 30 feet by 17.32, yun yung area. So that is, this is your pH, the horizontal component of the pressure acting on this curve. Now, what is PV? Yung vertical component naman ng total pressure acting on this curve is the weight of a volume of fluid intersecting vertically. So, ano yung, again, tubig ito. Okay, tubig yan. So, unit weight is 62.4. Ano ngayon itong volume na ito? Ano yung volume na yan? So, that volume is equal to, okay, that volume is equal to the length of the gate, which is 30 feet, times the area of this. Ano yung area niyan? So, ito yung area nun. Area ng ABC, okay, is equal to the area of A, B, C, F, rectangle yan, plus yung area ng triangle na to, CFO. Ibabawas natin itong area ng sector na yan, ACO, yun na lang yung matitira. So, yun yun. So, alam naman yung area ng rectangle. Alam yung area nitong triangle. At alam natin yung area ng sector, 1/6 ng circle yan. Kasi 60. 1/6 ito ng 360. So, yun yun. So, ito yung makukuha natin. Multiply this by the length of the gate, which is 30 feet. Ayun. So, substitute lang, 62.4 times this volume, that's PV. So, continuing the solution, saan ngayon ang location ng dalawang forces na kinuha natin? So, kanina nga, kinuha natin yung result, yung component. Ano yan eh, ito bali yung T. Ito bali yung P, and then kinuha natin yung kanyang component on the horizontal, yung hydrostatic force, tsaka ito yung vertical component nung total P na yan. Saan ngayon ang point of action? Again, locate natin yung pH. Where is pH located? So alam natin that the water surface is just plus here. So kung ito ay 17.32, ito ay magkakaroon lang ulit ng triangular diagram ng force. So again, ito ay nandun lang sa kalahati ng 17.32. No, not kalahati, 1/3. 1/3 from the base, 2/3 from the vertex, kasi that's how you locate the centroid of a triangular section. So alam na natin ang location ng pH. Yung PV, how do we locate? So nag-drawing tayo ng force triangle. Okay? So this PV first through this vertical, this pH first through this horizontal line, and they meet at point D. Okay? So ngayon, meron tayong triangle. Okay? This triangle is itong side na ito, itong vertical na ito represents PV, yung horizontal na yan represent pH, at yan naman ngayon yung pH, yung mula dun sa A, gaano kataas yung point of action ng pH, 17.32. Ito naman ngayon, okay, itong point E na to, nagre-represent kung saan from point O, saan nandun. This is the other side of the triangle. So, with respect to forces and the dimensions of the triangle, magkaroon tayo ng similar triangle. Okay, sulat natin na relationship between the forces and the dimensions of the triangle. So, PV is to ED, okay? Yung force na ito is to the length ED, as PH is to the length EO. Okay? So, yung ED, alam na natin. Okay? That is the point where the hydrostatic force is acting 1/3 from the base. So, that's 5.77. So, we have computed PV already. May PH na tayo. Okay? So, isa-substitute na lang natin. So, we find EO. Okay? 17.18 meters or feet from O. Yun yung point of action. Nandun located yung vertical component of the total hydrostatic force acting on the sector gate, or 2.81 meters from AB. Ito yung EA yan. Okay? So that's your solution for pagka ganyan, ano? Pag naman may instances dun sa inyong ating presentation last time, ito ay andito yung tubig, kaya yun ang pag-aanuhan nyo. Doon naman sa kunyari nando sa ilalim yung tubig, po-project nyo lang sa taas. So meron tayong provision para doon. Okay. Yung susunod nating lesson is about application ito ng mga previous problems natin. I-apply natin yan muna dito sa particular problem na ito about dams. Okay? So, I discuss ko muna before I present to you some sample problems on dams. Ano ba ang dam? Okay? Okay. Ang dam is ang structure yan. Okay? This is a structure para harangan. Okay? This is a structure that is used to store water. So, kunyari, meron kang na-discuss ko na ito sa inyo nung sa surveying. Kunyari, this is a body of water. So, gusto mong magkaroon ng storage dito, maglalagay ka ng obstruction. At yung obstruction na yon, yung harang na yon, ay dam. Okay? Andito. So, gusto mo, andito yung storage mo. Meron kang storage dito. Ang tawag dito ay reservoir. So, andito ngayon yung, so may dam ka. Okay? So, ito yung pag-aaralan natin. And a dam is a very massive structure, at kasi very massive din naman yung mga forces that act on this. So, i-classify natin yung dam according to ito, pag inano mo yan, pag kinuha mo yung cross section nito, pwedeng ang makita mo dyan is a trapezoidal dam. Trapezoidal yung section, andito yung tubig. So, ano ngayon? So, ito yung structure, ito yung cross section, napakaraming force na acting on the dam. So, yun yung pag-aaralan natin. At ang pag-aaralan natin about dams is paano ba siya i-design so that it is stable. It is stable. So, there are a lot of forces that may act on dam, yung hangin, yung volume ng tubig na kanyang pinipigil para umagos. So the hydrostatic pressure, pwede rin namang because this is a massive structure, depende sa kung anong material siya gawa, pwede siyang earth dam, pwede siyang earth-filled dam, pwede siyang masonry dam, concrete dam, combination of meron ding timber dam, basta yung structure is purposely constructed para ma-obstruct yung free flow ng tubig, ang tawag doon ay dam. So, di-discuss natin doon, ano ba yung mga pinag-aaralan para malaman mo na safe yung design. Okay? Yun ang ating pag-aaralan. Kung safe ba yung design, pag-aaralan natin. So, meron tayong mga factors of safety na kailangan i-consider, but that will be next time. Okay, class?